Okay, but first we'll start with some general information. Yeah. Come on. We'll leave a few minutes more because it's still very early. People barely have finished their meal. So for the newcomers, if you will want to practice at the same time that I would be showing stuff, you can check out the two repositories here. And you can start probably doing some, installing the dependencies, check out the README, install the dependencies, so you don't have to do that when we get to the actual practice. Should we start? I suppose. Okay, we'll start. Anyway, it's fairly generic information. I've seen that a lot of people. So a lot of people don't know React, but again, also I warn you that I'm not just going to be talking about React. This is just incidental, but that's a good occasion to clear some things about React. So React is a view layer. It's a virtual DOM engine. It's not an architecture. It's really something that is very decoupled from your architecture. And for developers that have to ramp up, it's generally very easy to get started. So even junior developers very quickly get their head around how it's working. It's not limited to DOM. So there's obviously the famous React Native that maybe you heard, but also you can have a React backend for Pixie.js or Canvas, general Canvas or SVG. So there are a number of backends, and you can write your own. So this has been created by a few people from Massive with external support from other people and contributions and advisors and testers. It's been deployed in production on our side, and I believe in other companies. There are interesting sources like the GitHub haxe-react org has a lot of quite advanced extents to use React components, and the React Native especially are within the React Native APIs are within the haxe-react organization, and there's some more add-ons under this other account. So about JSX, because it's not necessarily obvious to understand. So in JavaScript, it's something very, very terse and reasonably well integrated. So you write HTML-ish, and this is really just a declarative language. So it's a DSL to declare a certain structure, and that's converted by the compilers. So the Babel compiler, TypeScript compiler, they all are able to transform that, and they will transform that into calls to functions. So React create element, the tag is a div, it has an class name attribute, and it has children content, which is here is just a text. So as you can see, you could imagine that the div is not restricted to be a string. So this div could be a class. The class name could be a variable, and you can and this is a structure that is recursive, so you could pass more create element as children. And React create element itself do not instantiate anything specific. It only creates metadata. So this function really emits only a small JSON object that is, as you see, fairly simple. It has a magic property to identify that it's a React element, and then the props, the children, the type, which is the component we use. So there is a binding syntax. So you can use a class name. If you remember the code, so the string literal for class name could be a variable, and that's what we do. So we just use the curly brackets to pull in a variable, and that is just generated as having the variable literally instead of the command box string, and variable instead of the children text. So currently the best we can do for a DSL in Haxe is to use a macro function and passing a string for the template, which is what we hope we can make that linear, but it's reasonably compact, and that works the same. So you can use binding, you can use the JS6 style curly brackets binding, or you can use the Haxe style string interpolation, and which will work the same. The advantage is that with these brackets currently you have code completion for free, though we could have code completion for this once we improve the ghetto backend, the ghetto parser we have for haxe-react. I told you that React create element creates a bit of JavaScript code, a bit of a JavaScript object, and the haxe-react macro is able to generate literally this statically this JSON object without going through a function call, which is better than what you can obtain in JavaScript. That's for release mode. So as I say, the parser is fairly complete. It has a few limitations. It's not the best code, and we want to improve it and using the HHX backend, hopefully at some point. It supports the advanced feature that you don't know yet you need in React, like the spread operator, default values, and making stateless components. So the basics of React for the DOM is you call React DOM render, and you provide it with the template and a DOM element you want to render it in it, and that's the only thing you need to do on in your code, and that kicks all the React machinery, and everything will live on its own. You just need to call that once for each route you want to use, so that makes it a very good candidate when you migrate an application, because you can start using React render for specific components, then complete screens, then complete application. So as it has very low impact on your architecture, and you can have multiple React routes. It's pretty good for migrations, which has made it even more popular than it should be. So this initial render, if you pass it some static HTML, some just HTML content that will emit a static DOM, this DOM will never change. But if you want to add your application logic and some re-render and refreshes, then you have to use a component. So React component, I don't know if it's very visible, but so this, instead of using an HTML tag, I'm using a tag where the tag is in fact a Haxe class. So I'm supposed to have a my app class that is imported in this class, and then it can be used as a React component. And a React component, when it's going to be instantiated, will be able to trigger refresh. It will be able to change its state and trigger local refresh. So the absolute minimal you would have in a component is a render function that returns some JSX. So this render function. So again, when we look at that, React render is going to first create the metadata for my app. It's not going to instantiate it. Then React will run an actual rendering, creation of the components. And when this component is created, it will call the render function. And components will then emit some more JSX, and it will go in depth building all your views. This would be a static component. This component cannot update. So to update, you need to trigger state changes. So a state change is when you call this, when this component would execute set state with the value, it would trigger a re-render. And most of the time the re-render is synchronous, so you don't want to call set state too often. But sometimes this set state is will trigger an asynchronous re-render. It depends if you're in an event loop, like if you try to set state while you are handling a click event, a mouse event, it will not re-render. It will re-render after all the bubbling, all the messaging, either for the keys or for the mouse, has been processed through the DOM, and then it will re-render. And we can use the state. So components have a state. So we can push values because you're not allowed to edit the state directly, to mutate the state directly. You have to use set state. And then you can use the state when you render. So here I'm using a number here. Having just a state is not enough, so you need to configure your component, and to configure your component you pass it properties. So the props are passed as attribute. So up we create a my button with a title attribute, which means the my button class will receive a props title, and components will then mix props, which are the external configuration, which can change. So the parent can trigger a re-render and provide new props to the child, but the child is only able to change its own state. I'm trying to go very quickly and briefly on that, but that's the basics. You can avoid creating a class. So if you just want a very simple component, you can just define a function that receives the props as attributes, and it will render likewise. So you can use JSX with a function. It has currently have to have a capital, so it doesn't look like a tag, because it's not very smartly trying to detect whether that's a HTML tag or a local function. But basically we can just use a function instead of making a full-blown class with a render function. You can just use a function. That's the functional components. And just to finish about the avoiding bad practices, do not use inheritance if possible with React. Use composition. In that case we use a high order component, which is a component returning a single element which is not DOM, which is just another component. It will not have any impact on the DOM depth or the DOM complexity. It is just a component that can be configured from its parent and that can configure a child. So here we can do a uppercase button, and it will have the same API of the normal button, having a title, and this can return a normal button, just making the text uppercase. So that's the React way of dealing with components and inheritance, because you would use composition instead here.
Where does props come from in this
So the props would come like that. You would use a my button caps with a title, and the title is the prop.
It's an instant field from the React. Oh, then it's configured with the attributes. Okay.
So that's the configuration, which ends up as props. And so instead of my button, you could use my button caps, and then my button caps has the prop title, and it can pass it, use it as configuration to create other components. In that case, it uses just this other button. That's the preferred way of composing and extending components. You don't want to use normal inheritance, although that works in some on certain measure. That's the largely recommended way. Likewise, you can create wrappers. So if you instantiate a button, so there's the configuration as props, as attributes, and you can also provide children. So if you create a buttonize class and in HTML-ish provide child content, you will have that as props children, and you can return the DOM that you want or other components and pass around the children. So it's a very elegant system that has been really, at this point there's, I don't know, tens of alternatives nowadays, hundreds. Tens vaguely relevant, 3 relevant, but that's the idea, and it's really a very powerful way to declare UI. We've been through that at Massive. We've created enormous complex applications because everything was done by code instead of using the declarative system, and it's super tedious to maintain. While this looks a lot simpler to get your head around. I'm going to avoid the more advanced topic that I have later. So the pure components. Yeah, that's if you want to get into React, you look into all that. But I'm not going to. So just saying. So it's all working. It's in production for us in major projects. It just scales to extremely complex applications without any problems, and that makes fairly compact applications as well. As I was saying, so React doesn't give any architecture. It's not an architecture in itself. It's just a view. So you have to use it in an architecture where you will provide it data and handle application state and change and all that. So I've implemented 2 examples. So I've implemented 2 examples. So one based on Redux, based on the Redux library, and one based on MMVC, which is our MVC framework from Massive. But the principle should work. Both, should be are worth looking in terms of understanding how you can architect an application with React, because React has some constraints. So there's one example, which is the haxe-react Redux, which we're going to look a bit later. Not in terms of architecture, because really that's something that architects should be looking into and take their time to understand how it fits. And was it with MMVC, which is, you create your context, your dependency injection, the view mediators, etc., and all can be wired with React. Wiring that with React requires usually some fairly advanced understanding of React in the way you can provide context to child views. In this regard, these 2 examples are fairly important if you want to architect your application with React, because they will give you some ideas on how it can be achieved. And both of these examples, using Redux or using MMVC, leverage one of the key architectural principle of React is the context. So this mechanism is the way you provide objects and references to the children view. So this is a principle of producer and consumer. So you have a provider, a context provider, and then the children can consume the context to use it. So typically you could, if you think about MVC, you could provide through the context the injector, so that when the view mounts, it can run an injector that will do what is needed for MVC and dependency injection and creating the mediator, etc., etc. So it has to be used carefully and only when needed. So don't hurt yourself with that. But that's the way you architect applications. That's the way the React routing works. That's the way all these libraries work. So provider, consumer, and that's about it for the basic, for the general information about React. So I wanted to show you. Now this is also this project is, so we go back to the beginning. So if you want to check out the repository at the same time, so it's the second one, which is haxe-react Redux. So if you want to check it, if you want to play with the changes as well, at this one. So I don't know, it's going to be big enough. No, it's probably not, so let's try to. Right, so that's the project structure. So you have a build HXML, you have the package JSON because we're using React and other libraries from NPM. And it's using Haxe Modular. This one is using Haxe Modular to work. So it's a bit a silly example, obviously, but where is it? Right, so you have a bit of a to-do application. So it's just as a demonstration of architecture, and that's using React. So what is interesting is to look at the this application has been split. So I'm going to try to get you that. So this application is built with React. So you have the React DOM render here. So this is a React DOM render, and the GI6 is going to set up the application. So the entire application is wired through React. So and we're using these providers to configure the application. So we have this first provider is the Redux provider. Is going to give access to all the components to the Redux store. So Redux store is the globally it's a centrally managed application store. It's a very interesting architectural component. Has become quite popular. And so this configuration includes the store provider. Then we have the router. So it's using React router, and the React router is going to handle page navigations, and based on page navigation is going to render components. I won't explain how React router works because that's an entire topic in itself. But essentially, you have the index route, and then you have the about route. And they are provided to React not as not as direct class references. They're provided as bundles. So here it's using a special bundle, which is the route bundle, which is returning a function, returning an API compatible asynchronous component for React Router, and that is going to trigger a split. So it's going to split the to-do list screen and the about screen. So when I was showing you that, there's the to-do list screen and then the about screen, and we can navigate. So that's the index slash, and that's slash about, which is the about screen. And React Router will take care of creating the components and loading the component asynchronously. And by doing that, we can split our application by page. So we will create different bundles. And if I look at the bin output, you can see that I'm generating index. Oh, there's a bit of noise here. I'm going to delete that and build. Right, so I've built this simple application. As you can see, it's as fast as if you wouldn't do any splitting, but here you have the about screen and the to-do list screen, and they're both generated with their source map. And that is based that's the only code that defines that we are going to split the code into different components, into different bundles. And from that point, if I would go and look at the about screen haxe code, it is going to be very, very compact, because it will really only create the about screen, the about view that is in the screen, the footer that is on the screen, and the logo, because those are specific to this screen. And it looks like normal. It almost looks like normal haxe output, but it is going to. So that's using the standalone modular, and things are just going. The scopes are going to merge together, and it works as if it was a single script. So let's try to do some live reload. Do I have my server on? Okay. So this is the about screen, as you can see. So there's a div class about this demo, blah blah blah. There's state counter. So if I go and click here on the button, in here on top of the button, it says you have clicked X times. So this code in React is all wired like that. So you have the button, on click, it will call the on click handler. The on click handler changes the state. Changing the state will trigger a re-render, so that will call again the render function. The render function will return the metadata again. Don't forget, this only creates metadata, and the metadata then is compared by the React DOM diffing algorithm to find what has to be changed in the DOM. And if I look here at the elements, I'm going to inspect that. If we look at that, and if I click a button, you can see that only this in the entire, although we render the entire screen, the entire view, if I click the button, you can see here is going to blink. There's only the number blinking, because that's the only DOM element that effectively changed, and React will diff and only change this element, update this element. Right? Now, we're here and we say, this is going very slowly. I would like to increment by 10. right? And here it's saying, oh, reloading about screen, and then it's reloaded. So now if we're lucky, if I click it, now it's increasing by 10. We didn't lose the state we were. We still had the 8 count, which were the state of the view again. It's not something that is serialized. And I just went in the code and changed something. Edited that. And if I want, I can add some more content. Oopsie. Right, and you have right. Everything has been live updated, and now we're increasing by 1 because I changed the counter. And this is all. So you can imagine you're making your application. You have your 4 steps checkout. You're on the last screen trying to finish your form, your registration form, and you don't want to be doing redoing everything to get there. And that's essentially, you know, this is when you start doing that, that's really like a very addictive feeling that you don't have to rebuild your application, reload it, to update it. And so that's about that. So what we can see in the network is that every time I have changed, it has reloaded the JavaScript. And then internally it's using a React component proxy. So that's something that comes from the official Facebook effort to make React hot reload. And it's using the React proxy and the React deep force update and these kind of libraries that are on NPM and that allow so that proxies the component, so the components can be live updated when they're reloaded. And this is not done using Webpack, so this is completely standalone and free. The only thing we're using is live reload. So the server used is live reload X, and live reload X is an NPM local server that implements the live reload API. And this live reload API provides a listener. So the client can listen to, can be notified of changes, and instead of letting the system reload the page, we can say, hold on, I'm going to handle this JavaScript change, and I'm going to reload it and call some internal force update in the UI. So this is done using React, but there's no fundamental limitation, and it can be done with others. I know that other frameworks have worked on that, like Vue.js has worked as well on live reload. I didn't look at how it's implemented and how we could do that with haxe, but in principle, that's more or less always the same. You want to reload and have a system that can live update instances, because it's not creating a new instance of the about view component. It is live updating the methods in the prototype of this instance so that it can receive the updated code. So there's some pretty cool libraries that are at work here. Right, so any questions so far, maybe? No, since
I didn't understand the code split. Does it depend on the route, or when does this magic happen?
So in this case, we are using the routes to provide the asynchronous API, and the principle is that with modular, you use either the bundle load or the route bundle load to inform the splitter that this class and its dependencies should be split. You can use either like that, or you can manually manage your bundle load yourself. So if you have your own application router, or if you have your own, or if you just want to load to bundle just a component like a player, you know, it's just again the other example of doing that. Or if you would want to bundle your registration flow, you could say the moment or in the UI you click register or you want to register, you would execute bundle load registration, then it's available and we can show the screen. So it's just an example. That's a very typical way to work on splitting in JavaScript with React, because most applications are done using a router like React router, and this is very convenient to just say, okay, if you navigate to this page, then we will load the page. But that is not a limitation. You can arbitrarily asynchronously load anything. And oh yeah, for the magic, yeah, for the hot reload magic, it's here. So we get what is returned by React DOM app, and if we compile for debugging, we're going to call React hot module replacement and auto refresh that. And once that is executed, it will pull the needed code and infrastructure to hot reload your classes. Once the refreshing is finished, when the code has been reloaded, it will trigger the refreshing of the view automatically. That's essentially all. Yep.
I was playing actually with the haxe-react before, and I didn't find the answer to this question. So we have a about page as a sub page of the main, and the only way to get to this page is to open the main and then click to about.
Yes.
If I want to get to about directly.
So you, yes, absolutely. So the limitation we have right now is that Live Reload X does not do URL rewriting. So currently you cannot reload the page with /about, but that's a limitation of the server. In principle, if you would load your application to /about, and that would be, and React router would be able to get the URL, it would only load the about page. It would not load the home page. It will just load what has to be loaded. It will automatically pick the URL. It's just we have with the because right now I'm using the browser history. So I think if I would be using the hash history, maybe I could make it work. So the hash history. So if we go here. And if I go to about, it's now using the hash in the URL, so it's hash about. So now if I reload this page, so I'm going to clear that. If I reload this page, it has only loaded the about screen. It hasn't loaded the home screen. And that's React router doing its job automatically. It's just, usually you could use the hash history for debugging. And then, because that's not supported yet by the Live Reload X server, and otherwise, when you want to do your release, your real build, then you go back to browser history. So this is using the browser the HTML5 push API, so you can push a URL. So yeah, this works. React router in itself is a very interesting piece, but it's extremely complicated. Let's say it's very rich, very powerful, and it changes for every version. So this is React Router 3, and it's not compatible with React Router 4. So I'll have to look at updating the examples to use it. But it's really it's almost the industry standard for React applications. And we're still shipping applications with React Router 2 for what it's worth, so it's perfectly functional. So okay, let's try to do some live things. Yes?
Yeah, I was wondering why use XML for route definition. I mean, I get that it's useful for like components, but this is pure configuration.
This is can be discussed. The point here is that using React, here we use it because it's a fine mechanism to compose features and to define our dependencies here, and also you can. We're already making React components technically. Those are React components.
Oh, I see. So
It's all React components, and they will function and render what has to be rendered. So when you have the index route, so you have route matching / it will use the page wrapper. So the page wrapper gives us the navigation, and then it will create as children a sub-component with matching with the right route. So it will match the index route, or it will match the about route, and it will create the children. So it's a way to create your actual React structure, but in a way that it will be based on matching the path you're on.
So if we like have about in the URL, the index route will just do nothing.
Yes, it will not render.
Okay, thank you.
Yeah.
So is require is not defined. Does it compiling or requires that?
You're trying to compile this example? Okay, let me check. So we have an interesting case, which is the next step. We're going to try something really dangerous. Don't try it at home. So we have something which is a React component, which is the Google Map React, right? And we are going to add it to our project. So the tricky part with the modular is when you use modular is when you use npm modules. So if you want to use npm modules, in general, whatever you have JS require, etc., that works. However, you cannot. I don't know if you're familiar with Browserify, but you do not run anymore. If you use modular, you cannot run Browserify on the split bundles. So to use npm libraries, you have to create a registry, and this registry is done using a libs.js, which is where we are defining the registry. So I'm going to add a dependency. I'm going to add a Google Map React. So I add in require. So this is just the require. This libs.json is where we're going to pull all the npm repository, npm dependencies. The rest of the code doesn't change. Really, it's just copy paste that, add the npm libraries you need, and then once that is done, you need to run. We need to run npm run libs. So there's a. So this project comes with a package JSON that has a few commands, and basically what we do is we only browserify this JavaScript file. So it has a requires, and we run browserify on this one, and this is the only one ever that you browserify. Once that is done, all your bundles don't need to be browserified, and that's ultimately even faster because you don't need to compile your hacks and then run browserify in your hacks code. You just browserify libs. So that what so I've done that, and now we have the libs updated, and I can go in the about view. So I had already installed this library, but you would have to install the library properly. And now I can create the component. So the component is an extern class Google Map extends React component. Right. And we don't care what it's doing. And we're going to include this React component. So we just require it. It's going to be Google Map React. It needs to be, we need to get the default. So we need to get the default class from it. So that's a trick, a JS NPM trick. To know that, that's, yeah, this is slightly tricky to know whether you need to use the default or not. But the way you can know that is if it is using that. So if you see in an example for a React component something saying import that from, then that means this is the default. This is the default require. There's a default class, a default component, and you have to get it with default. So for default, if it's import foo from bar, you have to use that is default. You need to add the default. Otherwise, you would have something like import foo from bar. In that case, you need to import. Say let's add yes. I don't know how it's how far it is documented in the and here you want to do that. So that's the three cases you have if you use a command.js element. So it's either depending on the way the import is described, that's going to you will have to use a different import. If it's not in the documentation, it better be added, because that's a bit tricky when you get started with that. So I'm doing that. Yes.
Where does that libs.js come from? Do you create that?
Yeah, you have to create it. So it is something that is explained in the modular documentation. You just have to follow the template, and it creates something that will do create a registry object that will then be used by the different bundles. And that's a pattern that's been made for modular. So it means that all your dependencies will be in a separate JavaScript file, libs.js. So in the index, we load the libs.js and then your index. If that is bothering you, you can concatenate the two for production, so you have just one JS to load. But that's basically how you work with it.
Did you need to write libs.js in haxe-react, so to avoid as much as possible JS writing?
That probably would be possible, but much more verbose than this. And this, you just copy paste the template and add more requires in it. Maybe some, yeah. Maybe we could come up with some macro stuff that could do it. potentially.
I mean, you have this JS require metadata anyway. Couldn't you just iterate all types and generate this for all types that's in the metadata?
Could. Certainly could, yeah. Yeah, yeah.
Can't we just set XML for it? Can't we just set it like this?
So, yeah, so that's a bit of a workaround, so we could make that better with macro magic. I was focusing on the splitting itself and resolving that. This is pretty fine in terms of usage. We have a project using that, and that's really not problematic because you just create it once and then you forget. Then you take care of your code. You don't need to run Browserify anyway anymore. Well, so yeah, Google Maps. So I have a Google Map component. So to use it, we need to do a div style. So we need to wrap it in the div. Then you can Google Map. Zoom equals 15, center equals, and I'm going to get the coordinates because I don't know them by heart. And that's the location, right? God damn it. Div. So now I need to recompile the libs. Did I recompile the libs already? Yes, I did. So I did already recompile the libs because I changed the dependencies. I just run libs, npm run libs. As soon as when you change the libs.js, you need to recompile it to regenerate a new libs.js with the dependencies bundled in it. That just does Browserify. You know, that's very simple. We just Browserify this file. And now if that wants to build, no, it's something it doesn't like. Oh, yeah. That worked. We'll need to beep reload the page. Was it? Oopsie. Qu'est-ce qu'il y a? What did it? Missing map. No API key. Do you want an API key? You're not okay? Oopsie. He's not happy. He wants an API key. I don't remember how you give an API key to this thing. It loaded and then you say no. API key.
There's a link in the error message.
Yeah.
Yeah, but that's not the that's the link to Google. That's not the link for API key has to be provided as not this one, not this one. Which one? What about this one? Where was that? Where was that? Where is it with the key? Okay. Deprecated, but hopefully should still work. So let's try that. I had a key somewhere. Did I lost it? Oh no, I removed it. Did I? Whoopsie. Whoopsie. Oh, I'm not going to get a key. Anyway, that was working. You just need to go back to Google, generate your key, and then you have your component. So that's the main trick for this one. So there's still something which is like slightly awkward npm libs, but I just copy paste the template, add the require, and that's done. And effectively, as I said, so this just work with any Haxe project. So I can go and use another project and check Parrot Pig. You remember Parrot Pig, right? Yeah. Where is Parrot Pig? It's here. So if I want to run it, if I run the project, oh, it's here. It's already running here, I suppose. Yeah, so it's Parrot Pig. You know this one, right? I suppose I'm not giving you not showing new things. Now look at what happened when we loaded. Oh, it's loading two JavaScript files. One is index, and one is the game itself. And that's OpenFL split. So you have basically the core framework in the main JS. And then you have the game, and that's a very, very trivial game. And as things can go more complicated, it can be interesting to have that split. So what does it look like in the code? What did I change? Where is the main class? Parrot Pig, and here it is. So in the initialize function of Parrot Pig, instead of creating the parrot game and everything, I use bundle load of Parrot Pig game, right? Is it big enough? And when it's loaded, so I delayed the creation of the footer. I know that because they're using they're using for the layout properties for the game, because this is not a very nicely architectured game. So there's a lot of dependencies that shouldn't be here. But basically, I'm creating the footer with the game, and then I can add them and resize it. So this just doing that. This is the only change I did really. Adding this bundle load, and here in the resize function, checking whether the game was null or not. And that's exactly the same code, and that is just split. That's all. It emits and loads the two JavaScript files. Yep.
So what happens if you access the Pirate Pig game before you even load it?
Well, you can't access it before you loaded it, because it's a because you're running a promise. So if you use the class Pirate Pig game before it's loaded, well, it will crash with a null pointer exception because the class is not ready, and then it's loaded and then it's ready. That's all.
So what actually happens there behind the scenes?
So what happens? I think we need to check a much smaller project. So so what happens? Right, let's check back that and look at the index here. So this is our index for the Redux project. So there's a loading, and this is how it's done. So this is how it's loaded, so the promise is called with so it's using an interval class which is require, and this is going to load a JavaScript file called example to do view to do screen.js, and when that is loaded, it calls back this the promise. Here we do some scope binding, so we make the to-do-screen class accessible. So that's in directed code. It gets the class that was created that was loaded in the other JavaScript file and makes it available locally. So from that point, when we use reference this class, then it is available. Can probably actually get the PyPy code. So require module. So that's what is happening. So we do require module, then, and that's the rest of the code is doing new pirate pick game. It's here, and so this has been loaded, wired, and then this is in the main class, the asynchronous code that does create the footer, set the smoothing, create the game, add side, etc. From that point on, this is normal Haxe code, like no trickery, no nothing. This is just normal Haxe code because the scopes have been brought together.
What's this ID?
ID is the name of the module. So the callback gives you the name of the module that you loaded. So if you send that to a function, it knows what's. If you send all your asynchronous loads to the same handler, then it knows what has been loaded. Yeah, so there's some trickery to export and make available classes. So there's which is there's a global HX scope where things are attached, and when you're going to get that, so this class is going to use from the scope. You know, this is all the classes that come from. Probably need to wrap it. View toggle wrap. So we have all the. So we reference all the classes from OpenFO that are needed by the module here. So we have them available here. And at the end, this is going to export. This is going to export what has to be available. So at the end, it does. So this is the scope, hx scope dot. So it's sharing then to the shared scope the references to the classes that are exported. And we just have to wire them together, and it works.
Could it be done several times, as many as you want?
You can do as many. You can create as many modules as you want. Now the algorithm that that splits the modules is currently is not super smart. If you want, is that as soon as so we have the main module, and then you create the other modules. So if you create several modules that share the same classes somehow, even if they're not used in the main module, they will be hoisted in the main module, so that they are available to all the submodules. So it could be made slightly more intelligently, and if you have 2 modules from 10 that share the same code, we could create a common module that will be loaded. But that makes things a lot more complicated right now, and that is the current compromise.
When I want to make a plugin system, so that certain modules are not known at the time the whole thing is compiled, it's not possible.
Well, if you want to use this system, then you probably will have to use a more generic system, more traditional, where you create different projects. I'm not sure it would work with that. No, I don't think it would work. I think you would want to use the normal, like the haxe exports, and then resolving this global exports in your code. Because the thing is that if you have something dynamic, you don't know the classes that you're going to manipulate. So you're in the realm where you're going to manipulate dynamically objects. So it's not the case of you have your fully typed explicit application that you can identify that and cut that out. Then we could check the Webpack version. So the Webpack example. So we have an app. It's very similar. The difference is that now we can require styles. I would like to find a better syntax for that because we have a floating require. We try to find something clever, but that requires the style for the application. Then it will render the root component and trigger the React auto refresh. That's the same API as with Modular, but that will be working with Webpack. And in the root class, we can. So in the root class, I decided to load the foo component asynchronously. So I'm using the explicit Webpack load, and when it's loaded, I set the components I want to render to this class reference. And now I can render the content. So here, if I have a component, I can render the component. So either I don't have any component in the state, and I render loading, and when I have a component, I can render the component. So I'm using Webpack load to get the foo class, and it's going to be asynchronous. And this foo class is using its own styles, an image, a configuration, and I can use it. So I can use the image as the URL. I can get some data from the config, from the JSON file. The JSON file is just this object, so it has a hello property. So I can require this config and do config.hello. So yes, in Haxe you would want to use macros and stuff, but just showing it's working. It's not strictly typed and all that. I have an amazing JSON to strictly type class, and it all disappears in the code using inlining, and it's beautiful, but that works. And that
I guess type hint the config.
you could use a type def for the config, yes. But that is, you don't need to parse it, you don't need to load it, and yes, you could do better with a macro, but that's pretty simple and explicit, and it's just showing that you can do that with Webpack. And technically, if you would want to make this JSON an XML file, you could do file loader. By doing that, I would say this JSON file should not be inlined as JavaScript. It should be moved into an XML file. And actually, config will be your URL to the JSON file. So then you would have to load it, parse it as usual. But that can be all integrated within Webpack, and you can override even the default rules that have been set for loading assets and files. This is extremely powerful. So if I run that, to run that, I need a command line. What do we have open? I'm going to close things. All right. So to run that, we yarn or npm run, npm start, and I'm going to show that's quite interesting. So I'm going to. Right, I'm removing, completely deleting the output, and I'll start. So Webpack will set up a server, a dev server. It will run the compilation, and everything is ready and running now. So the configuration is, so we've tried a lot to make that documented and all that, But essentially, I've said that the entry point is build.hxml. So Webpack was with an entry point. That's the main thing in Webpack. As a bundler, you give him the entry point, just like in Haxe you give the main class. And then from that point, it will go and get everything. And the entry point can be an HTML file now. And we have the different configuration for the dev server, for the module loader. So we have the Haxe loader, we have the file loader for the images, the CSS loader for the styles. We have some plugins that are going to do the hot module replacement, some option plugin, generation of the index HTML. So we generate the index HTML, we don't create any one. You can provide an alternative template to it. It's an extremely flexible system. And so it's built now and running, and I can go and, which one is that? Localhost 900, is it? Yep, it is. So this has been loaded asynchronously, so it's well, in that case React even didn't create multiple modules, although we used an asynchronous require. It should have decided that the module we require is too small to be moved into a separate file, but technically they are two JavaScript files. And I mean technically, I mean in memory, because there is no www. Webpack dev server works absolutely in memory. So when you're in dev, it is not generating a single thing on your computer. It's all in memory. The index has been generated in memory. The Webpack code has been split and provided in memory. The assets, like the images, are all sitting in memory. The styles. Until I do a release build, it's going to just stay in memory. And so this is where we say, let's do some HMR, guys. And I find that is a bit silly, so hello Haxe Summit, right? And hello Haxe Summit. And you can see that it has loaded a small JavaScript file, which is our bundle corresponding to the route, to the foo route. That we effectively internally for Webpack we generate multiple JavaScript files, and depending on the splitting algorithm, it will decide or not to put that in different bundles. But it still has a file it can reload and re-inject to get our code. And as you see, we've had the Haxe live reload happening. It has just re-rendered the view. So if we inspect that, you can see there's the images, there's the text. If I go and change the text, right? Hopla, you see it has just updated just this text node, because this is the only thing when diffing the renders it has decided has changed. So it has reloaded and all that. What else? You can go and change the text. So this one, what's the class? Oh, it's a class foo. Let's do some changes. So the class foo, we're going to change the background to make it fancier, right? And this is the kind of thing that Webpack does on its own. So if you use the styles loader, it is one of the first hot modules that Webpack supports out of the box. So if you save and change CSS, the styles loader will reload it. But that also works here. Is it still working here? Are we still working? Are we still served? Or not? Oh, I killed it. Let's go to React Redux. We're going to bin. Right, now we're loading, and I can go and change some styles. So I can go in here. What is that? it's the stats view. Let's change the stats view. So where are the styles? CSS, index CSS, stats view, and let's make it the same very desirable background. And that is handled by library Redux. It does automatically swap and refresh CSS. So you also get this kind of workflow, possibly even faster than Webpack, because it's very simply replacing the styles and refreshing it. I believe it's also able to replace static images. So if you have a static image displayed, and if you update the image, it's going to refresh the image in the browser as well. So it's a pretty nice. It works pretty nicely in practice.
So how does it determine what to replace? You mentioned the thing. Does it actually diff the new output and figure out?
Yes. Yes.
Isn't that pretty expensive?
Well, that's less expensive than re-rendering the DOM.
Yeah,
It,
I guess.
yeah, no, but it's something that is pretty finely tuned, and between the different libraries like React and P-React, which is an alternative, they have very fast diffing algorithms. Yeah, definitely. But you want to contain that, and with React you have to contain that and write logic to. Normally you want to update the state of a component, and just this component will render and its children possibly. Though if it renders the first level of children, if the props haven't changed, it's not going to re-render the child. So it has a fairly advanced diffing algorithm here that is surprisingly working quite efficiently, even on low power devices. So we have that on the crappiest set-top boxes and smart TVs, and that's working very well. And using React, which is not considered as the fastest one. So P-React is a React alternative that is API compatible, and that is supposedly faster, but it has some slightly different behavior in what we found out, that it tended to recreate your component, re-instantiate your components, your instances, instead of keeping the old instances. So they have slightly different profiles, but it's something working really well, in fact. Yeah, and there are ways to contain the change. So you can add a function which is called should update. So when there's a state or props change, React will say, hey, should you update with these new props and state? And you can say no, and it will not call the re-render. Right. So for the rest of the time, and I'm like open to questions now. We can try something further if you want to try, but basically it would be interesting to discuss. We can discuss in terms of architecture, depending on your architecture, how you think, or if you want advice on how you should break down that to leverage the splitting. Yeah.
Nearby question.
Yeah.
What exactly is React Native? Is it like a renderer for the virtual DOM that uses like native widgets, or what is it?
Well, that's it. So all the metadata that are shown, these JavaScript objects, instead of being used to generate DOM, they are sent to the native side, and a diffing algorithm is going to run on iOS native or Android native and create native views from it. Once again, didn't show too much about React. One of the cool things is you can look at that. This is there's a provider, a router, context router, a link element. This is our to-do screen list, to-do list view, and you can inspect your React components and see what DOM they generated. You can see the data they had. So it had some props. You can see the props. You can see their state. You can see all the callbacks I've put in place.
Cannot point to hax code.
What is that tool you're using to do the inspection?
This is the React Chrome plugin. So if you basically, if you run just a debug version of React in your browser, you check the console is going to say, hey, you should install the Chrome debugger, the Chrome React plugin, and you click the link and you get the extension. And in that case, I can go and check the components, what they have, what are their properties. We can also see the context where we provide it, which used to provide context to the children, so we can see what is received. And as it is Redux, with Redux there's also a Redux inspector, and I can check the data of my application. So my application has this data. It has the entries on my items in that list. And I can check all the information and all the actions that happened. And if I go in and check, uncheck, I can go in the past. I can retrigger the state change. I can go back to the beginning when there was no data and replay it. You can see all the messages that used to update the state, and you can check your global data. It's very interesting as an architecture building block, because it's not an architecture by itself, is that it works very well with server-side rendering, because this state, this global state, you can render your page on the server, store the state as a JavaScript object, and when your application loads, it can reuse the state as is. And then with React, you can also assimilate the React DOM so that it doesn't re-render. But that's a very different advanced topic. But that Redux fits very, very well in server-side rendering approach. Other questions?
So how do you write native views? So if we want to port this application to iPhone, for example.
With React Native,
Yeah.
you should check the haxe-react organization from Kevin, where I believe there's an example now. It shows you how you use the native views. So you have to use a different API. You can't use DOM, div. You don't use divs, etc. You have to use view, list, button from the.
So we can't write cross-platform code.
So it could work on the other way. Is that some people are working on a DOM-based rendering of the React Native components. So if you make your application using React Native views and things like that, then it has a fallback set of components that would work on DOM. I'm not sure how mature this is, but it is nonetheless a fairly interesting thing to check. Question there, sorry. How you split what?
OpenFL from your game code. And I guess that target was model is basically an entry point in your game. How you will split the game, which is dependent on OpenFL, and also on libraries, which are dependent on OpenFL. Because library not necessarily have entry point.
Well, the thing is that I don't split OpenFL. OpenFL is, if it is naturally essentially what ends up as in your main index, because your main class, your main OpenFL class is when you see the generate code, so your application main references OpenFL, creates, displays, shows the preloader. So basically the boot sequence of your application is using OpenFL, and by using OpenFL it imports all these classes in your main bundle. So, and that is kind of unavoidable because the loading phase of OpenFL is done using OpenFL. If it was not using OpenFL, then we could completely split OpenFL. But in that case, it's dragged naturally by the loader. And what you cut then in your project is you want to have the entry point that kind of sets up your project, and then either you keep your game, I mean the game basics as in the main bundle, and then you load additional features, like you will load your, as I was saying, you can load the multiplayer lobby, the world editor, you can load the registration forms, you can load whatever. What you want to do is to define your user journey as what are the minimal set of code and features that are needed at startup, and all the rest I try to load them on demand.
The template of the HTML for the React can be written in an HTML file and loaded in Python.
For what part?
When you wrote the render functions,
Yes.
JSX, you had some template inside it. Can it be an external file?
So the React templating is traditionally not externalized. It is usually the render functions is the whole point of JSX was to say, hey, we're going to use our descriptive interface directly within the code. And currently we don't support using an external file, but I think that could be quite possibly done. Some people, you have an import.
It's built right in the parser, in fact.
You have an import, so yeah, there may be some. Could probably be done to use something external if you would want, yes.
But then we had a big discussion in Docker whether we want that or not, and the biggest problem is that you cannot trick the compiler into giving you autocompletion when it's not in a hex file.
Yeah, because we're using variables like the state, and all this. This will be enforced by the compiler, and you can get some completion here when you use expressions, local expressions. So as soon as you use that, it's a bit inconvenient. I mean, it's not very convenient to have that external.
So, what exactly parses the stuff inside the JSX? That's the parser you wrote, right?
Yes, that's an XML parser, and with a bit of transformations on it.
Okay, so you parse XML and then deal with the replacement sort of stuff in some way, basically.
Yeah, currently, as I said, it's a bit ghetto here. So we parse the first time and add the quotes where they are missing to be valid XML and use the XML parser. But I want to move to something which is a purely native parser for that.
Okay.
And I mean, it's basically, yes, parsing a string. Now you do it more or less elegantly, but that basically, yes, you have to parse it and then emit the code. So if we look at the generated code for that, for a project like that, if we look at the generated code, so so the about view has div, class name, about, render, about this demo, etc. So I'm going to open the script for it, and I'm going to search for the about view. I have the render function, and this is my JSX. It's here, right? It's my render function. So it does React create element, blah blah blah, create element P, H2, button, binding the on-click event for the button, and all this code is, so all the declarative code is transformed like that, which is, you wouldn't want to write that yourself. That would be rather inconvenient. And if we were to do a release build of that, so now if I go and say haxe build to make a release build, oh, what did I change in about view? Did I? Oh, whoopsie, yes. Yes, in valid JSX, so our ghetto parser still gives you some information of what is wrong. And so it's regenerated. So if I look at the generated code now, it's become literal JS objects instead of the function calls to create element. Yeah, there's some weird code generation here happening.
Yeah, you should use X4 probably.
So, and there's just one de-optimization happening, is that Google Map is an external component. So it falls back to create element, because there are some things that we cannot, because this JS object has to include a number of data and information that in the case of external components may not be available at compile time. So they have to be resolved by the runtime React create elements. So this is a de-optimization for NPM component. But globally, this is so many function calls avoided here. Could be made much more compact in terms of generation.
Can you show your build HXML file quickly? Yeah. Do you mind if I try some?
I'm on 342.
Yeah, I know. I forget if it works on 2.2. Try compiling it again. Nothing is gonna change probably, but maybe it does.
So modular gives you a number of information about your processing. So this is the, I don't know if you see it. So there's the AST parsing. Then you have some stats. Then it processes the graph, and then it extracts the chunks. So it will emit a number of files, and that's the total processing of 200 milliseconds on this like low machine. What's the difference in the code generation?
Nothing, great.
Nothing.
Okay, you should upgrade that.
We'll try. Yeah, so by the way, code splitting works from haxe-react plus. So it's, even if you have an old project, you can go and try to get it optimized.
Does it rely on how we generate JavaScript right now? Because,
Slightly,
I mean,
yes.
so it can, we should be careful about changing the output.
It's normally not. I mean, yes, if you change the layout of the output, but it's based on the AST, so it's not really based on the layout itself. But if potentially if you do change to output, yeah, it would be interesting to have a discussion on what you change. But as I say, it's fairly robust, though it works from the 3.13 to 3.42. So there's been quite a few changes between these versions, and it's all supported. There's been discussions as well as around some of the fallback functions. So the fallback code, for instance, for data view, typed arrays, I think that's something that could make it. It's slightly inconvenient to detect and split them correctly, but I got it working. But I think the other projects like Modular.js and HXJS have problems dealing with that. So there's a limitation with Modular, is that it doesn't like if you do if you have too complex code in your static init, for the magic static init, if you use that, because it's hard for these tools to identify what the static init does and where it should go, and how to split it. So if you want to do a static init, and that's something that we need. That is a bit of a problem in OpenF, and that should be changed. So if you do a static init, I would advise to use another static function to not put the code here, and you use a static function like apply init. And if you do that, this is going to be perfectly split, because the code splitting will identify the code to apply init as a bit of code that has to be extracted and inserted and moved in the bundle where this class is declared, and there will be no ambiguity. But if you're here and you say var foo equals blah blah blah, etc., this is not going to be split properly. The var foo is going to be created, is going to be duplicated in every bundle. So every code that is not identified properly is going to move in all the bundles. So var foo is going to happen in all the scripts, because when parsing, we don't know where it comes from. Using maybe in the future hxgen.js to do the processing without going through the haxe output intermediary step could solve it, but that's slightly longer term. Right now this works and splits some fairly big scripts without problems. So that no, of course not. It's been quite a work in progress, and our test is that we have a large application, and if it doesn't die, then it's good. No, I need to get on that and do some tests for the common cases, so we can test for regressions. Certainly need to do that.
Can you show something in production which uses
I'm not yet allowed to show you something that uses React right now in production, but it's not in this region either, so you will not be able to see it. Yeah, so no. Other questions? Do you want to go and discuss about your project, about how maybe discuss how you could apply that, and we can continue like that. Right. So any other questions right now? No. We're good. So that's done. Let's now discuss together if you have more if you want to see how to apply that to your project. Okay. That's all.